Okay, so today we're going to finish up the notes on 3.3. We're still going to be using synthetic division for the end of the notes here. So tonight's homework is 3.3b. Today what we're going to do first is called the remainder theorem. So here, if a polynomial f of x is divided by x minus k, then it'll be the remainder, or it'll be r, this is a typo, it'll be r is equal to, the remainder is going to be equal to f of k. So this should be a typo, this should be an equal sign. So I'm going to show you what this means. So we're going to go ahead and try our first example. Now, whenever they give you a polynomial and then they say find f of a number, then we're going to be doing synthetic division with that number that's in the parentheses. Now, before when we did it, they were giving it to you as like like x minus 2 or x plus 2. And then it was the opposite. Whenever it's asking you to find f of a number, we're going to actually use that exact number because that is the x value. That's our solution. So let's go ahead and sometimes they're going to say this number that's here is f of k, if you look back on the other slide. So it says they want us to find when k equals negative 2. So I'm going to do synthetic division. I'm going to put negative 2, this number, on the outside. Let me put all my coefficients inside this division box. And now I can start my synthetic division. Same thing that you just did for homework last night. We're going to bring down the first term. We're going to multiply 3 times negative 2. I get negative 6. I'm going to add the column. I'm going to multiply 2 times negative 2. Write that product in that next column. Add the column. Multiply again. The 1 times the negative 2. Add the column. And my remainder here is the answer to the problem. So f of 2 is equal to negative 9. So it's going to be equal to the remainder. And what this is this is an order pair that we could graph for this polynomial. So another way to do this is you could have plugged in negative 2 into that original polynomial equation every place that you saw an x, and you can get the same answer that way as well. What this is doing is this is giving us an order pair or our y value for the order pair. Now, when you go to enter this in WebAssign, what they're going to do, they're going to ask you to write your answer in this form. So they're going to say, write your answer as x minus k, and then they're going to say q of x plus r. So the x minus k, what they're going to do here in this particular problem, my k value was negative 2. So what I'm putting in here is x minus negative 2. So then this will become x plus 2. Then the q of x is just the original function. So it'll be 3x squared. I'm sorry, no, the answer, sorry. It's this part of it. The answer we got here. So it's going to be, remember we're going to add in, this is remainder, constant, x squared. So the q of x part of this is going to be this over here. It's going to be 3x squared. Let me erase this. Be 3x squared plus 2x plus 1. And then you put the remainder on the outside of the parentheses. So when you go to do your homework tonight, you're going to do the synthetic division, but you're going to take the k value and you're going to put it here, x minus k, and because it's negative, it turns into a plus. Then you take the result of the synthetic division, that's what goes here, and then the remainder over here. I'll try it with the next one, and I'll show you what we're doing there as well. So for the next one, we're doing the same thing. We're going to do a synthetic division problem. 4, take all the coefficients. So 4, 10, -3, -8. Bring down, multiply. I get 16. Add the column. I get 26. Multiply. I get 104. Add the column. 101. Multiply again. One last time. 4 times 101, 404. Add the column, 396. So the answer when k equals 4, this order pair that you would have graphed would be 4, 396. However, f of 4 equals 396. To write this answer in WebAssign, remember this bottom row here, this is the remainder, the constant, the x squared term. So when I write this in WebAssign, again, they're going to say x minus k times the q of x, which is the answer, the quotient, plus the remainder. So again, I'm going to put in here x minus 4, because that's what they told me to divide by. Then the quotient is this part right here with the variables. So it's going to be 4x squared plus 26x plus 101. And then the remainder plus 396. And I think I added that wrong. I wrote my numbers backwards, I think. So that's how you're going to key it into WebAssign. Now, another part of it, it's going to have an A part and a B part. So the answer to A is that. The answer to part B in the WebAssign is just the remainder. So on the same one up here, this would have been the answer for part A. Part B here is going to be -9. So you're going to write it in the format for A, but the B answer is the remainder. So in the homework, the third question, they're just going to give you like polynomials like this. And the third question in the homework might say instead of f of 4, they might also have f of 0, f of 10, whatever it is. And you're just going to plug these numbers and do synthetic division. So just like I did here, and I got 396, I'll do another synthetic division, but now use a 0 or use a 10. So when you get to number 3 in the homework, that's all you're doing. Okay, remember when we're doing synthetic division, it's bringing our problem down a power, and our goal is to get it to something quadratic that I can either use completing the square, quadratic formula, or factor to get the rest of my answers. So let's try another example. Now we're going to use the factor theorem. We're going to test to see if something's a factor. So for the factor theorem, this is stating that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So if we get a remainder of 0, then we know it's a factor. It divides in evenly. So when you're given a solution, you're going to use synthetic division to reduce the degree of the initial polynomial. So our goal is to get it to quadratic. And then I can either use factoring, quadratic formula, completing the square, whatever technique you want to use once it's quadratic to find the remaining roots. Remember, whenever you see a question on an SAT or on my test or any kind of test you're taking, whenever it says to find the roots, to find the zeros, to find solutions, to find x-intercepts, all of this is the same thing. You're still doing the same technique. You're going to get it to quadratic and then find the remaining roots by quadratic formula, factoring, or completing the square. So again, all of these things here, the roots, the solutions, the zeros, x-intercepts, is where my graph is going to touch the x-axis. They're x-intercepts. So let's go ahead and try some more synthetic division, and we're going to determine if something is a factor. And again, to determine if it's a factor, our goal is to get a remainder of 0. So let's try the first one. So they're giving us the function f of x. They want us to check to see if x minus 2 is a factor. So remember, when they give it to you in this form, we're setting it equal to 0, and the number or the k value that we're plugging in here or doing the synthetic with is going to be opposite. But if it says determine if 2 is a solution, then we would actually use that number. So here I'm going to put the 2. I'm taking all the coefficients. So the 2, the 7, the -4, the -27, the -18. And I'm going to do synthetic division. If I get a remainder of 0, then I will say yes, x minus 2 is a factor. If my remainder is not 0, then my answer is no, it's not a factor. So let's try it. We're going to bring down. We're going to multiply. 2 times 2 is 4. You're going to add the column. You're going to multiply. We get 22. We're going to add the column. We get 18. We're going to multiply. Is that yellow? No, let me do it in another color. Well, I'll just do it in black. 2 times 18 is 36. I'm going to add the column. I get 9. Then I'm going to multiply one more time. 2 times 9 is 18. Wow, I got a remainder of 0. So yes, x minus 2 is a factor. If I did not get a remainder of 0 right here, then the answer would have been no. So let's try the next one. Now, also remember that the power that's up here that you start with, this tells you how many factors you should end up getting once you're all done. And this is leading us coming up later on. Right now, we're just testing to see if something's a factor. But if I were to have solved all of this, there would have ended up being 4 factors for this polynomial, or 4 x-intercepts. Now, keep in mind that sometimes the factors repeat. And we're going to learn that that's like a touch and turn or a bounce when we graph our polynomials. But let's go ahead. So the 2 over here, when we solved it and did the synthetic, this is a root or an x-intercept. So now let's try the next one. They want us to see if x plus 3 is a factor. So again, x plus 3 equals 0. The number I'm going to use in my synthetic division, which is checking to see if this is a root, is going to be -3. So again, I'm using the same function. Same coefficients, 2, 7, -4, -27, -18. I'm going to bring down. I'm going to multiply. I get -6. I'm going to add the column. I'm going to multiply. I'm going to add the column. I'm going to multiply. I get positive 21. I'm going to add the column. I get -6. I'm going to multiply one more time. I get positive 18. And again, I got a remainder of 0. So again, x plus 3 is a factor. This answer is yes. Now, what we're going to do is to show you how you can find all 4 factors. Remember, what's happened here is every time I do a synthetic division, this brings this down a power. So what I'm going to do here is I'm going to take the bottom row here, and I'm going to do synthetic division using a different number. So for example, if I tried to do synthetic with -3 again, because actually -3 is actually going to, or actually let me go ahead and do it with the +2 that I did up above. So let's say instead I did it with -3. Now what I can do is I can take this bottom row and do another synthetic division problem. Because what this now turns into, if you think about it, this is r constant x, x squared, x cubed. So now it's 2x cubed plus x minus 7x minus 6 equals 0. So what I can do now is I still can't factor this. I could try to factor it by grouping, but it doesn't work. So I'm going to do another synthetic division now with this answer. So I'm going to put all of this in my synthetic division box. So I'm going to use 2 and 1 and -7 and -6. And I'm going to use the 2 that they'd asked me to do at the beginning. So now I'm going to do a synthetic division with that answer. Bring down. Multiply. Add the column. Multiply again. Add the column. Multiply again. And I get a remainder of 0 again. So I already knew 2 was a factor because I already done it on number 12. So now I have a quadratic. So now remainder, constant, x, x squared. So now I have 2x squared plus 5x plus 3. I now have a quadratic equation that I can either factor, use quadratic formula, or completing the square to get my other 2 factors. So I already have x minus 2 and x plus 3 as factors. I need to find the other 2 because remember my power at the beginning was a 4. So let's factor this. It's actually factorable. It'll factor into 2x plus 3 and x plus 1. So if it asks you to list the factors of that polynomial, it'll be x minus 2, x plus 3, 2x plus 3, and x plus 1. If it asks you to list the solutions, and this is what it's going to ask you to do in the homework, or actually it's going to say find the zeros. So then now I take each factor, set them equal to 0, add 2, x equals 2, subtract 3, subtract 3, divide by 2, x equals -3 over 2, subtract 1, and it's a -1. So when you enter this in WebAssign, it's going to tell you to enter them separated by commas. I don't know if it says least to greatest. You can check that. But if it doesn't, let's just go ahead and do it least to greatest. So I would do -3, -3 over 2, or you could also enter it as 1.5, then -1, and then +2. So WebAssign is going to tell you to find the zeros, and it's going to tell you to enter them and separate them with commas. So all you're going to do is list the solutions or the zeros or the roots. It all means the same thing. Let's try another one. Now this is actually the graph of this one. So if you notice, the zeros I got, -3, let me do it, -1.5, -1, +2. These are all the x-intercepts or the zeros or the solutions, whatever terminology they use, it all means the same thing. It's where my graph touches the x-axis. We're going to be graphing these polynomials starting tomorrow. I believe this was Desmos. So I use Desmos. It's an app you can get on your iPad. You cannot use Desmos for the test, but you could use it to do your homework if you want to check your answers. Pretty good there? All right, let's try another example. So given that x plus 3 is a factor of that function. It wants me to find all factors and zeros. So I've done the graphing utility. I used Desmos again. I keyed it in. And once I'm done here, my answers that I should be getting are going to be -3, -2, and 5. These are going to be the 3 answers I get. Notice the exponent on my function is a 3. This tells me I should be getting 3 answers. So let's go ahead and try it. Again, we're going to take our x plus 3, set it equal to 0. So the root, or the answer I'm using to do the synthetic, is -3. So I'm going to do -3, take all the coefficients. Notice it's missing an x squared. You need to hold the place. So 1, 0, -19, and -30. So I'm going to bring down. I'm going to multiply. -3 times 1. Add the column. Multiply again. -3 times -3. I get +9. Add the column. -19. I'm going to multiply. I get +30. I got a remainder of 0. So again, they told me that it was a factor. So if I did not get a 0 as my remainder, I did something wrong because they already told me that this is going to work. Now, my goal here is to bring down the power, so now it's quadratic. So this is remainder, constant, x squared. I now have the function x squared minus 3x minus 10 equals 0. It's now a quadratic equation that I can either factor, use completing the square, or quadratic formula to get my other 2 factors. This is factorable. Factoring for me is the fastest way. If you're still struggling with factoring, use quadratic formula by all means. If it can't be factored, you have to use quadratic formula or completing the square. So this will factor into x minus 5 and x plus 2. So again, if I ever ask you to list just the factors are this row right here. However, in WebAssign, they want the solutions. So what we're going to do is set x plus 3 equal to 0, x minus 5 equal to 0, x plus 2 equal to 0. So then now what we're going to do is subtract. X equals -3. Add the 5. Subtract the 2. X equals 2. So in WebAssign, you would enter it as 3, 2, 5. These are zeros. These are the solutions. These are the x-intercepts. So these are zeros. They're also called solutions. They're also called roots. They're also called x-intercepts right here. But these guys in the blue box, these are the factors. Thank you. -2. Thanks. Good catch. All right, everybody good? Let's try another one. So this was the same graph that was there. Notice the 3 zeros I got were -3, -2, +5. Same graph. Let's try one more example. In WebAssign tonight, it's going to ask you to have 3 parts for the like number 6 and 7. It's going to say list and round to 3 decimal places. It's going to say give exact value of one of the zeros. And it says use exact in the synthetic to find the other factors. So what this is going to tell me is my roots are going to be radicals. So let's try this one, and then I'll show you how you're going to enter this into WebAssign. So we're going to go ahead and do synthetic here. Now, what we're going to do is to find the one that's synthetic here, we have to key this in our calculator. So once I key it into my calculator, I'm going to find that one of my exact values is going to be +2. So that's what I'm going to do here. And I'm going to show you this if I have time with my calculator. So here, so my first 0 that I found is going to be the +2. And I'm going to do synthetic division here to get this down to quadratic, because right now it's a cube. So I'm going to bring down, going to multiply, add the column, multiply, add the column, multiply, add the column. Notice I got a remainder of 0. So I already knew 2 is going to be a root or a solution. So now remainder, constant, x squared. So I have x squared minus 2 equals 0. To get my other two zeros, I need to solve this. So I can solve this by doing, if it asks you to list the factors are going to be the square root of 2. So it's going to x squared, and I can add the 2, square root it. So my two solutions are going to be plus and minus root 2. So my three solutions are going to be negative root 2, positive root 2, and positive 2. These are my x-intercepts. Now, when you key the square root of 2 on your calculator, it's actually 1.414. So this negative square root 2 is negative 4.14. This is positive, and then 2. So for part A, you're going to key it in as a decimal, and they're going to say round to 3 decimal places. For part B, they want the exact answer, so here you're going to key in just the 2. And then for the factor portion, part C, you're going to key this in as x minus square root 2, x plus square root 2, and then x minus 2. So basically flip all the signs to opposite, and then, actually, let me put it this way so it corresponds with the above root. So this one is this one in factored form, this one, and then this one. So in WebAssign, you're going to have to do the radical on your calculator, round it to 3 decimal places. For part B, where it wants to know the real part, I think, let me see what the terminology they use. The exact answer, so no decimals, no radicals. And then you're going to list the factors. These are like the last 2 questions. So again, if we look, this is the graph of that function that's on the prior slide. And you're going to get a question like this on your test where you're going to have to find one of the rational zeros. These other ones that have these crazy decimals, the negative 1.414, these are radicals. So when you're taking the test, I'm going to expect you to put it in radical form, not in decimal form. But tonight, WebAssign is going to want the decimal for part A, and then for part B, it's going to want the exact, and then for part C, it's going to want the radical answers. So what you're going to do is you're going to key this in WebAssign. You're going to find, in a graphing utility, you're going to key it into either Desmos or your graphing calculator to get one of the exact zeros. And my exact zero here is 2. So let me go, where is it zoomed in? And again, this is using Desmos. So if you haven't gotten your calculator, you might want to get one before you take the test next week. All you do is over here, you would key in the equation or the function. And then again, when you're trying to do this and they don't give you a factor to do the synthetic with, you're looking for the number that's not a crazy decimal. So for example, this is why I did the synthetic with the positive 2. These are the two square root 2 answers. We would not do synthetic division with a radical. So that is it for using synthetic division to find order pairs that you could graph to figure out if something is a factor. What we're going to be doing tomorrow is graphing these polynomials using synthetic division to find all your order pairs.